This video is being recorded for ETL 682. The target audience is a freshman Intro to Engineering class. Hello class, this is the West Point Bridge Designer software. I'm going to be giving you a quick rundown of how to use this software and optimize a bridge for your upcoming assignment. The link to this software is available on Access. If you go to the home page, go to the very bottom, there is a link for you to download. If you have a Mac or a PC, the link is available for you there. If you have a Chromebook, unfortunately this software is unavailable for you. Okay, so once you have this software downloaded, you will open it, and on your first run it will look like this. There are some tips of the day that you can click through and read. They are helpful to get started, but I'm going to show you everything you need to know. So I'm actually going to uncheck this box so this doesn't show up again, and I'm going to close the tip. Once you do that, this window shows up asking you if you'd like to load a sample bridge design, load an existing bridge design, or create a new design. And I'm going to create a new design. So I have create a new design selected. I'm going to hit OK. And then there are a bunch of options here. Later on we can play with these, but for right now I want everybody to use the same settings. So we're just going to click next until we can get started. So I'll hit next, and then right away I run into my first issue. For some reason the aspect ratio on my screen, the next button, which should be right here, doesn't show. Fortunately, you can just click enter a bunch of times until it starts. So I just hit enter several times, and then we got to the main bridge building menu. So this is the scenario where we will be building our bridge. There are many menu options here that you should be familiar with. But let's start building, and then as those options become relevant, I will show you how to use them. So first things first, these little circles here are anchor points. You're going to be building your bridge out of beams, and beams have to be supported at both ends. So we need to put anchorages wherever we want to connect a beam. From an earlier lesson, you guys should recall that building something like a bridge out of squares is not ideal because of a phenomenon called parallelogramming. Therefore, rather than using squares or quadrilaterals, I'm going to build my bridge out of triangles. So we're making a bunch of equilateral triangles here. We also discussed the advantages of equilateral triangles, at least in real life. The practical benefits of using equilateral triangles are all of your members are the same. It cuts down on material cost and it makes it much easier to build. Okay, so I have built a bridge. I made several anchor points along the top, and I connected every anchorage with a beam. So my bridge is entirely made up of equilateral triangles. Now, just for illustration's sake, I'm going to erase one of these beams. So now I've got a quadrilateral here, which is capable of parallelogramming, which is not good. If I try to run the software, it actually identifies this fact, and it tells me that my structural model is unstable. When it does that, it means one of several things. First of all, you could have, like we have here, a parallelogram. You could also have a long unsupported section that doesn't have a beam in the center. You could have unconnected beams or anchorages that are not connected as well. So there are several different forms of instabilities. Generally, when this happens, you're either going to have a quadrilateral or a long unsupported section or an anchorage that's not connected. So let's add this beam back in, and then let's run our simulation. So we've built our bridge, at least our initial design, and we want to run the simulation and see if our bridge works. In order to do that, you will go right up here to this blue button that says Run the Load Test Animation and click that, and then we'll see what happens. Okay, so it goes to the live view of our bridge, and right away we can see that our bridge collapsed. It was not strong enough to support its own weight. The truck didn't even make it to try crossing the bridge. So we can go back to the drawing board and we can improve upon this bridge so that the truck does make it across. In order to get back to the drawing board, right next to the Run Animation button is another button that says Show the Drawing Board View. So we'll click on that and we'll get back to our diagram. And then we'll see a few things have changed. First of all, we see these beams here with these red hash marks on them. These beams failed, and specifically they failed in compression. There was too much compressive force on these beams and they buckled under the load. If we look over here on the right, there is this menu that shows data about all of our beams. There is a column that says compression, and if we click on that column a couple times, it'll sort our beams in order of most to least compressive force. And we'll see that all of these ones up here, which are highlighted in red, have numbers greater than 1. This column here, what it is essentially is it is showing what percent of maximum load the beam is under. So for example, this beam right here, it's under 81% of its max load, which means it's plenty strong enough to hold up and it's not going to fail. This beam, however, is under 143% of its max load, meaning there's too much force for the beam. There's a few things that we can do to fix that. Right now, I'm going to do the simplest thing, and I'm just going to make all of these beams here thicker. And then the same thing would be true of the tension column. But since I changed one thing, all of my load calculations are going to change. So I'm going to run the simulation again, see if my bridge collapses, which it does, and then I'll go back to the drawing board. So all of these same beams have failed, but you may have noticed that these numbers in this column got a little bit lower. This one I think said something around 1.41. Now it says 1.17, so we're much closer to not failing. The goal here is to get these numbers under 1. So I'm going to highlight all of these beams again, and I'm also going to highlight these beams in blue over here. The beams in blue are not failing in compression. In fact, they're failing in tension. There's too much force on the ends of the beam pulling them apart, and the beam will actually stretch and break apart. So the same thing needs to be done. It needs to be made stronger. And one way we can do that, the simplest way, and the way we'll be doing right now, is to make those beams thicker. So let's do that again. In order to make the beams thicker, I've already used this button, but I didn't explain it. There is a big square right here with an up arrow above the square. If we hover over that, it says increase the size of the selected members, so it'll raise them to the next size available. Right next to that is a button that says decrease the size of the selected members, and we'll use that in a little bit. So let's take these beams, let's make them thicker, and let's run our simulation again. One tip that I would volunteer to you is that you don't actually have to wait and watch the entire simulation to see if your bridge collapses. What you can do instead is go right up here to where it says status. Right now we see a red circle. That means the bridge is going to collapse. The bridge is going to fail its test. However, when the bridge doesn't fail, when the bridge passes the test, this would show a green arrow. So when you run your simulation, you don't have to watch. All you have to do is look over here to see if there's a red circle or a green arrow. In this case, we got a red circle. Our bridge failed, which we can see right here. So we'll go back to the drawing board and make some more tweaks. Okay, so the beams we made thicker are still selected. And if you notice, 2 of the beams that we made thicker last time are no longer failing. This means we're making progress. So let's take the beams that are still failing, highlight those. To do that, I'm just clicking and dragging, hovering over them. If I want to select more beams that are elsewhere, I can hold Control and click and highlight those beams as well. So I'm going to select all of these beams that are still failing. I'm going to make my bridge thicker, run the simulation. Red circle means it'll fail. We'll go back to the drawing board, and then we'll make just the ones that are failing thicker. And I don't want to keep doing this 1,000 times, so I'm just going to make them really thick to speed this process along. Now it looks like the bridge might pass, so we're getting really close. And I was able to know beforehand that it was going to collapse by looking at this status indicator right here. Okay, back to the drawing board. We are very close. We only have 2 beams failing now. So we're going to make those 2 beams thicker, and there's our green arrow. So this time our truck will finally make it across. And there he goes. It'll keep looping this animation, but we've now satisfied the task of making a bridge that is successful. However, the secondary task for this assignment for you is now to make a bridge that is as cheap as possible. If you look right here, the software will calculate the running total of your bridge. Currently, the bridge that I have designed is $402,000. The target for your assignment is $250,000. I would like you to optimize your bridge such that it is as cheap as possible while still being an effective bridge. So we are far above that number. We need to bring the cost of this bridge down. So I'm going to show you a few ways to do that. Let's get back to the drawing board. The first thing I like to do is try and use less material. Our bridge is made out of steel. Steel costs money, and if we can use less steel, in general, our bridge should be cheaper. So one thing I'm going to do is highlight all of my beams, which I can do by dragging. I can also do that by clicking this All button here. I'm going to select every beam, and I'm going to make them all one size thinner. Now, this will make the bridge fail, and I'll show you that right now. And we know that because last time we made 2 beams thicker to make the bridge successful. So we've gone back and made those beams smaller again. So the bridge was bound to fail. But if we go back to our drawing board, we'll see that though we made every beam thinner, only 5 beams failed. So let's take those 5 beams and make them thicker and try again. And we'll see here our status indicator shows that our bridge passes the test. If we go over and look at the cost of our bridge, we'll see that our bridge is now under $360,000. We just decreased the cost of this bridge by 10%. This is a process that you can go through many times to lower the cost of your bridge. And in fact, we are going to go ahead and get this bridge under $250,000 to show you that this can be done. So the bridge just failed again after we made every beam thinner, but we can take the beams that are failing and we can make them thicker again. We can run our simulation and see that we have a successful bridge design that's now $30,000 cheaper than it was before. I'm going to speedily go through several of these iterations to see how fast we can approach that $250,000 mark. So bear with me just a moment as I rapidly click through this. I'm just doing the same process, I'm just not narrating every step. Here we have a successful bridge. We've gone through 2 more iterations of making the beams thinner, thereby saving material, and we're now under $300,000. This bridge, as it stands, would get you about a B. Okay, let's take our bridge, let's try and save some more material. And now, as you can see, we've made them 2 thicknesses or 2 sizes thinner, and almost every beam is failing. So we are approaching the limit of this design. However, there are other steps we can take, and I will show you what those steps are momentarily. So here we are. One more beam that I missed. Okay, 283,000. It seems to me that our cost isn't going down much anymore when we go through this step. So I want to try something else. Here we are. In fact, we may not be going down any more at all. Okay, through that iteration, we only went down by $2,000. We would have to do that 15 more times in order to get to the target goal of $250,000. So let's try something else. I'm going to go back to the drawing board. I'd like to show you that currently we are on the 21st iteration of this design, and you can click back and go back to previous designs that could have been more or less successful. However, currently we are on the most successful version of this bridge, so I'm not going to do that right now. That can also be done by clicking on this arrow and looking at your previous designs. We are going to continue working with this design, and there's a couple things that we can do. The first thing that we can do is I'm going to highlight all of my beams, and we can actually switch the material that we're using. Currently, this bridge is made entirely of carbon steel. we can go to that menu and we can select another material. Carbon steel is the